Hello and welcome to Chatterjee Tutoring. In this video, I'll be going over binary search for beginners, the absolute basics. You don't have to know anything to watch this video. I'll just be showing a small implementation at the end, but other than that, I'll just be showing the main ideas of a binary search. First of all, if we want to use binary search, we first have to know what the problem is. Basically, the problem is, given a sorted array, let's say the array name is nums, you have to find the index where the target number occurs. For example, if we are given this nums array and we have to find this target. If we are given this nums array and this target, then the easy but slow method would be just to do a linear scan. What does this mean? This means that we just scan each and every number starting with the first number until we find the target. So we go one by one, starting from the first number, and for each number we compare with the target to find the index where the target number is. If we are trying to quantify how slow this algorithm is, we would say the complexity of this algorithm is big O of n. This basically means that for an average case, where n is the size of the nums array, we basically have to do, on average, n comparisons. Basically, this is too slow for us. We can use the fact that the nums array is sorted in order to find the number. How do we do this? Basically, the intuition is that since the nums array is sorted, the smaller numbers have to be towards the front and the bigger numbers have to be towards the back. Basically, in order to formalize this, we take the middle element of the search space and compare it with the target. We find the middle element by using this formula, low plus high divided by 2, and truncate the decimal. And this is how we shrink the search space each time. If the target is less than the mid, we know that the target must be on the left side of the array because this array is sorted. And if the target is greater than the mid, then we know that the target must be on the right side of the array. Let's take an example. If we're trying to search for 13 over here, on the first iteration, the search space is the entire array, but we take the middle element, which is 8, because we have four numbers on either side. So we take 8, we see 13 is greater than 8, so we know that 13 must be in the last 4 elements of the array. So we can shrink the search space to just the last 4 elements of the array. Now we take the middle element again. In this time, the middle element, since there's an even number of elements in the array, it will be on just the left of the middle, so the middle will be 21. Here we see that 21 is greater than 13. So 13 must be on the left of 21. So we can shrink the search space again to just the number 13, and since there's only one element in our search space, this must be it. Since we are shrinking the search space essentially in half each and every time, the complexity for this one will be big O of log base 2 of n, which is much less than big O of n once n gets sufficiently large. Now let's see how you can implement this algorithm in actual code. I'll be showing two implementations. One is the recursive method and the other is the iterative method. Both do the exact same thing and do it the same way, just using recursion or iteration. Basically, for both of these methods, the low and high variables will be representing the sample space that we are searching in. We will not be searching in the entire array each and every time that we compare with the middle and shrink the space. So we need to keep track of where the bounds for our search space is. So that is the low and high variables. Our base case for the recursion is that if low is greater than high, we shrunk the sample space so much that we did not find the target, then we return -1, meaning the target is not in the nums array at all. And if low is less than or equal to high, we can get the middle value by using the same algorithm that I showed before. We first compare the target with the element in the middle of the array, because if we have that, then we don't need to search anymore. We already found the index. Or else, if the target is less than the element in the middle of the array, then that means that we have to search on the left. So the next time that we call the binary search method recursively, we pass the same low, except we pass, instead of high, we pass mid minus 1. That represents shrinking the sample space to half of what it originally was. And if target is greater than nums at mid, then we, instead of passing the same low, we pass the mid plus 1 and the same high. For the iterative solution, it's basically the exact same thing. We have a low and high, which start at the first element and the last element in the array. We take the same steps as before. We first get the mid. We check the target against the mid. If it is the same, then we just return the index, or else we can update our either low or high variables accordingly. And that's it. Thanks for watching. If you have any questions or concerns, please leave a comment down below. And if you want tutoring in Java or computer science algorithms, then hop on over to chatterjeetutoring.com, where you can sign up for computer science lessons. Anyways, that's it. Have a great day.